What I have here is a SlimQ power supply, sold as a charger. It's got two USB-C outputs plus an XT60 connector for high amperage output, and it claims to be rated 330 watts. Gallium nitride construction. I mean, theoretically it's possible. We got to see how big it is and how heavy it is to know if that makes sense. Package seems reasonably heavy. You also might notice, well, it's not all visible here. You might notice I have a bunch of test equipment set out, and that is to answer my primary two questions. One, can it actually supply 330 watts at a go? And that's why I have 3 electronic loads. And also, how much noise does it have when it's supplying that wattage or just a high wattage? And as I said, this has 3 outputs, so hence 3 loads. So we can test all the outputs at once or one at a time, and 3 input cables on the oscilloscope. So, quick unboxing. Comes in a pouch, which I actually wasn't expecting, and this is sold for, in addition to just, any USB-C device, it is sold for laptops, especially for high amperage laptops. And that is really what the XT60 connector on this is for. And as you can see on this cover flap, it's rated 20 volts only on the XT60 connector. Presumably the USB-Cs will negotiate whatever voltage it needs. And there's the connector. And the idea is that this company should have included an XT62, I think, barrel plug connector. Yep, there it is. And so you plug this into here, and then either this directly into your laptop, if that fits your laptop, which it probably won't, and then the company sells separately a variety of adapters that will change this barrel plug to either the barrel plug or whatever weird square plug Lenovo uses of your choice. One thing I don't like about that is when, especially with high current loads, why are you adding an extra connection point in line? In other words, it would be better if they sold a variety of cables with different plugs on them that had an XT60 connector on the other end. So this way it minimizes the number of interconnects, which also, as we all know, these barrel plugs eventually over time can get a little loose. The pin can stop making contact inside the barrel. You could get intermittent connections or no connections. So even if it was at a premium cost, because obviously more expensive to sell a bunch of different cables than just a bunch of different adapters for the cable. So the idea is you plug that into there, and now this is your laptop power supply, in addition to having 200-watt USB-C ports. And the only other thing of note in here is, of course, a power connector, standard Mickey Mouse plug. And I think this is a metal case, which I guess would kind of be necessary for heat sinking. I mean, this is a small package. And just for comparison, let me grab this. This, I guess until I got this one here, was the most powerful USB-C power supply that I had. And this one is rated at 250 watts total, not just on one port. And it also depends on the combination of ports. But anyway, this is capable of delivering 250 watts. This one, 330. Form factor wise, the 330 watt one is bigger, which one would expect.
The Interruption.
Alright, me from the future here. I do not like this device. The reason it's me from the future is because in this video I'm going to be doing a number of tests on this power supply. It passes with flying colors. It seemed like a good power supply. Didn't have a problem with it. Until I ran it for 4 hours on a 300 watt load. That's 15 amps at 20 volts. This is rated for 330 watts max, keep in mind. Even though I unplugged it maybe 10-15 minutes ago, it's still too hot to touch with human hands. Unprotected human hands, anyway. Obviously, I have a human hand under here, but you know what I mean. This thing is just nonsense. The top of it got up to about 85 degrees C, and the bottom, which was on the table, because it has feet on the bottom, so it should be on the table, got up to 101 degrees C as soon as I took it off the table and pointed the thermal imaging camera at it. That test is at the end of the video. Reason I'm holding off on that, and I'll say this shortly in the video, is because I didn't want to ruin it before I could do the other tests if it died. It did not die during the stress test. It put out 20 volts, 15 amps for 4 hours, no problem, no voltage drop, no major issues, except for the fact that if you were doing that and then you went to go, let's say, check out of your hotel room or whatever, finish what you were doing and put this back in your bag, your suitcase, whatever, and you picked it up with your hand, with your bare hand, you'd probably burn yourself. I mean, 100 degrees C, like, you know, stick your hand in some boiling water. It's not safe from that perspective. So regardless of all the good things I'm going to say about this power supply in this video, my net recommendation is don't buy it. I'll get more into that at the end. And now, back to the video. Sorry for interrupting myself. And this is hefty, but it could just be this one's a little denser. I'm really curious to see how they weigh. And weighing something isn't conclusive as to the quality or current handling capabilities of the product, but they kind of do go hand in hand often enough, which makes sense because more current, thicker traces on the PCBs, bigger components, therefore heavier. So I got my little scale here. We don't need a hugely accurate measurement. I just want to get a basis of comparison. So this is 605 grams. And this is made by Anker. I actually don't even know how to pronounce their name, even though I own a few of their products. Not an advertisement. I could give a crap whether you buy one or not, but I've generally found their products to be good quality, so that's why I've bought a bunch of them. And that's why I bought this. 640 grams. So it's 640 versus 610-ish. So this is actually slightly heavier, even though it's physically smaller, which would make me suspicious of this saying it could handle 80 watts more in total than this guy. But who knows? And I guess I should actually, I haven't run this through its paces, but I really should, because I trust their brand, but that's kind of blind trust, because it's held out under heavy load. I don't know that I've loaded it with 250 watts, but it has been fine. Ew, and I need something to monitor the incoming power as well, so we know how much this is drawing. But for now, let's just see if it blows up. It did not. It has a power LED on it, and if I cup it and put it right to my eye, I can see that it's on. I don't know how well I can demonstrate this, because it's super dim. I mean, it's bright in here in general, but let me unplug it. And probably it's a capacitor that needs to discharge. Okay, I'm going to cup it, and let me plug it in and see if it comes back on, if we can tell even. No? I swear it is glowing like a faint orange. Well, let's see if it's supplying any voltage. Okay, 20.130 volts. And I guess I'll just move the case aside. Oh, otherwise we have the user manual, which can't possibly be that interesting. It does say power light, but I would call it more like a power dark. And here it iterates that max 100 watts, power delivery 3.0, port 2 also 100 watts, also 3.0. And then the XT60 connector, max 330 watts, 20 volts, which is therefore 16.5 amps. So that can provide power to even very power-hungry laptops. Interesting. So the LED is orange under normal circumstances, and then it'll orange flash when the power consumption is over approximately 320 watts. And it could go a little bit over the 330 watts rated, but I guess plus or minus 10 watts puts it at 330. And then let us drop it below 280 watts, plus or minus 10. And then we got this little orange booklet. Yeah, it just shows other products they have, like USB cables. And this is a sort of list of the adapters you can get for laptops. And I'll show a couple of those later in the video, along with testing it with a few laptops, if it doesn't provide horribly unstable and disgusting power, which we'll see. That's why I'm testing it with this equipment before connecting my precious laptops or cell phone to it. And the one thing I forgot, let me get something to monitor the inlet power so you can see how efficient it is as well. I almost completely forgot about my wacky test box. This is something I made in a previous video. We have a big on-off switch, power in, on the other end, power out, and in the middle, this probably, tremendously unsafe, yet expertly manufactured, as you can see, box with a circuit breaker, input power indicator, another power switch. This is like an emergency power switch, if you really need to shut off in a hurry, or, you know, far away from it, in case this whole thing's on fire and you don't want to touch it. And then basically what we have is line and neutral, and if these switches are on, current just passes straight through. If these switches are off, it breaks the circuit, and I can insert something with banana plugs here and here. And in case you're wondering about the color scheme, obviously green ground. The reason I use blue and yellow for line voltage is because obviously it could otherwise be confused with red and black for DC. So if I'm running multiple things on the bench that are connected via banana plugs, this way I know blue, yellow, don't touch, that doesn't rhyme. Blue and yellow, let it mellow. Red and black, touch it all you want. That's the idea behind it. I know it's not standard, and then we have 2 more indicator LEDs there and there. Not the prettiest looking thing, but it works. At least I think it works. Let me plug it in. Yeah, and this flash is just to show you that it's on. That was just sort of for fun. It also was a buzzer, but I disabled the buzzing. And you can see we also have a voltage indicator and amperage indicator. These are both very approximate because these are not high quality components. That's just to give a ballpark. And here's where I drilled something out by mistake and then covered it with this thing. So not what we'd call manufacturably electrically safe. Like, I couldn't sell this. People would die. But we do have the safety banana plugs. I can't stick my finger in there. Yeah, shrouded banana jacks. That's what I was going to say. Yeah, and then those LEDs indicate we got line and neutral. So I could shut them off like that. And then, real quick, let me talk about what else I brought over here. This is already getting dangerously crowded. This is a BK Precision 535B power meter. And let's all ignore the fact that it says requires calibration on the top. And it's missing a knob, and I got it cheap off eBay. So really, who knows? The reason I got this danger box out is because that works with this device, which measures voltage and current, but up to 20 amps max current and 600 volts max voltage, AC or DC, I think being no matter. And then this will monitor voltage and power consumption. And what I've got here are 2 cables, incorrectly color-coded, but it's the only banana to spade cables I have. So those can go onto the current posts here. And then for voltage, I will probably just highly this is super dangerous, by the way. This is all going to be live at mains voltage. And obviously there's a lot of bare metal here. So that is why there are 2 power switches here. And I'm going to plug this into a GFI just in case. Not that makes it, you know, unkillable to you. It's just, yeah. So we're going to send the current. We'll leave this switch off, so we'll bypass this connection here. And instead, the current will flow from one of these to the other through this device. And then I'll tap off of this one and also grab a shrouded banana plug cable for line voltage. I'm just putting on the neutral because, I don't know, this way if I leave this switch off, there's no voltage flowing through this. It doesn't matter. It doesn't really matter. But it's going on the neutral. And polarity doesn't matter here, of course. Actually, it's probably going to trigger some people. I put the red on the black connector and the black on the red connector. And then for voltage monitoring, I'm going to use one super dangerous cable. And I'm going to use one shrouded. And now we put this up here. And so then for the comically dangerous box, I should go through line just because I like the coloring better. Blue there. And then yellow will complete the circuit. And then we want to monitor the voltage here. So we're going to need this one on, this one off. So anything we plug into this will be monitorable by this. And obviously what we're going to plug into that is the power supply itself. And I'm plugging it into my power strip over here, which is in turn plugged into a GFI. Turn that on, turn that on. And so you can see we got, let me get that off the edge there. We got 0 amps on that reading, but we have 2 LED indicators there and there. So we should have power flowing into the power supply. And because the power supply's LED is, and because the power supply's LED is pretty much unnoticeable, let's just verify, this is the reverse polarity, I guess, but whatever, that we have 20 volts, if this would make contact. Yep, And to go along with this, I didn't have any XT60 connectors or cables with XT60 connectors, so I bought a couple. This one in particular for testing this power supply, because it's got these two big lugs on one end, the connector on the other, and I believe this is supposed to be 12 gauge or maybe 10, no, 12. It is 12 gauge cabling, which should be enough for, well, 20 amps or more in a short run like this. These two electronic loads are both capable of 300 watts. This one is only 200 watts, but that's fine because we can use that to test one of the USB-C and then USB-C, and then eventually I'll use a combination of two of these to add 330 watts of load to this device, actually maybe a little higher, to see what happens. But for now, as long as we got a BK Precision power meter, let's use the BK Precision load. So really what I want to see is, even can this thing supply anywhere near its rated load? This is the wrong polarity of connector. I'm an idiot. Whoops. Well, it wouldn't be one of my videos if I didn't goof up somewhere, but fortunately, I also have this extension cable, which has a male on one and female on the other, so... Oh, nice aluminum wire. See, these I'm pretty sure are copper, at least very thin aluminum strands. It does look like 12 gauge, but let's call it, 12 gauge aluminum, which on a short run like this, I mean, it's not going to be much resistance overall. Okay, take two. So now, what we do is we plug this into here. We got 20.1 volts on this device, and we're seeing about 12 watts right now with a really shit power factor. We'll start with 1 amp, and it is supplying 1 amp just fine, which is obviously 20 watts. And just by comparison, we're seeing 25 watts on the input side, and the power factor just got a lot better, so it's just bad power factor in standby. And let's push the current up to, I don't know, 5 amps. And that should, of course, be 100 watts. I mean, it is 100 watts, but it's 100 and call it 9 watts on the input. So pretty efficient, but I guess that's what you expect with gallium nitride. So let's just go for the gusto now and do 200 watts. So that'd be 10 amps. Voltage is, I mean, this is not monitoring the voltage separately. We will look at it with the oscilloscope, and I was going to say maybe with some more accurate voltage monitoring, but this is pretty accurate. I don't need it to any more than really 1 decimal point, because we just really want to see if the voltage is sagging below like a usable level. And whether this is 19.93 volts or 20.01 volts, if this is a little bit off, it doesn't really matter. Whatever equipment's connected to this will be happy enough. And now let's push the electronic load to its maximum, which would be 15 amps. Alright, so that's 300 watts. That's as high as this can go, basically. The voltage is a little less than 20, so there's technically some headroom. And we can see here it's pulling 320 watts on the input with almost a unity power factor. I mean, if that's great. And that's 2.7331 amps. And just for the record, the danger box is reading 2.5 amps on its little crappy display there. So we're still pulling 300 watts from this thing. And, ow. No, I'm just kidding. It's actually still pretty much room temperature. And I think I said it was metal before, but it's plastic. It just looked metallic in the light. It does have that shine to it, like it's anodized aluminum or something, but it's definitely plastic. Which isn't it's not necessarily a good thing that this isn't warm, because this is putting out 300 watts to my electronic load. But it's pulling 321.7 watts from the mains. So that means this device right here, in its relatively compact size, is somehow dissipating about 22 watts of power. And that really should be dissipated as heat, because it's not making noise or shooting out a blinding light. So the fact that it doesn't feel warm, I would characterize as a bad thing, because that means that heat is trapped in here, and it's not being synced out. Because 20 watts is not a lot of heat in general, but in a package this size, 20 watts is a decent amount of heat. But I guess what remains now is, you know what, actually, I was going to say what I'm going to do right now is leave this running for like 15 minutes, come back and look at it, 30 minutes, etc., and run it for maybe an hour, and see if it does get hot, if the voltage does sag, if it shuts down completely, anything of the sort. Now it's starting to get a little warm on the bottom, just a touch. I can just feel it slightly higher than body temperature. Again, it's been generating 20 watts of heat this entire time, presumably, so that's not necessarily good. But I don't want to do a long-running stress test on this just yet. And the reason for that is that if the stress test breaks it, if a component melts down inside, then we can't do any of our other tests. So I'll do the stress test last, or almost last. If you're going to run a power supply like this at nearly full load or full load, you're usually better off putting it that way, so you're not thermally insulating one complete side of it against a table or other surface. Actually, what I just said is technically incorrect. You would be insulating one complete side of it, but it would be the smallest side by area that you could lay this on. Or this side, but you know what I mean. You know what I'm saying. Just leave as much surface area of the device exposed to air as possible. It's getting warm. Anyway, let's move on. Next, I want to test the USB outputs independently. Each one, see if it can provide 100 watts. And then we'll move on to the rest of the testing, once we verify this at least has basic functionality. Alright, so for testing the USB ports, what I've got are these little adapters. I don't know what you want to call them. I guess they're adapters. And I made these myself. Well, made is a strong word. What I did is I took two 14-gauge wires and soldered them onto a little PCB with a USB-C jack. And that PCB notably has a power delivery chip that'll negotiate 20 volts. And then attached to that is just a USB-C male-to-male cable that's rated 100 watts max, which is exactly what we need to test these ports at. So all I'm going to be doing is clamping the ends of these wires into the posts on the electronic loads. So I got one USB connection to this electronic load, one to this one, and then the one up here is still connected to the XT60 connector. So like I said, these ports should do 100 watts apiece, and the thing in total can do 330 watts. We should be able to draw 100 watts from each of the USB-C connectors while simultaneously drawing 130 watts from the XT60 connector. We'll try that, but first, just put load on one USB port and see how that goes. So 20 watts, I mean, not surprising that it could handle that, being as it did handle 300 watts earlier. So let's just crank it up to 5 amps, the full 100 watts. And we're seeing a bit of a voltage drop now. Ideally, I'll be measuring the voltage at the connector here. Unfortunately, I can't right now. I don't have any way of splitting off that USB-C. But that's a rational voltage drop, I think, across this cable, this connector, and then these cables. So I don't think that's anything to do with the power supply. That seems reasonable. The Rigol load here is connected to the other USB-C port. Let's just do 5 amps. And there we go, about the same voltage drop. I'm going to turn off this one, and we'll see if the voltage rises on this one. It did rise a little bit. So that's not due to voltage drop on the cable. That was due to voltage drop on the power supply. Because if we enable that one now... I mean, it's not much, though. Yeah, it's a few hundredths of a volt. So, yeah, not a big deal at all. Because of the voltage drop, even though it says 96.6 watts here, I'm fairly safe in assuming that it's actually pulling 100 watts at the power supply. And same with this guy. And so we should have 130 watts headroom on the power supply. I'm just going to start with this at 5 amps. We get a clean 100 watts on this, and we'll just see how it goes. I just want to see the voltage drop on this display. 19.309, 19.290. So, yeah, again, not much of a voltage drop with the extra 5 amps of load. Again, we're drawing 300 watts from the output, and it is consuming 326 watts from the mains. And notice tonight my voltage is a little lower than it was yesterday. And now I guess let's try the full power supply rated load, so 6.5 amps. It'll be 130 watts at 20 volts. And once again, the power supply is not... Yeah, it's slightly warm, but only slightly. And like I said, this one is off the XT60 connector, and it's got thicker cabling, less junctions. It's just a higher amperage connector overall. So here we would really be seeing a pretty accurate voltage, even at 6.5 amps. There won't be much voltage drop on these cables, so that's really what the PSU is putting out on the output. And that's near as makes no difference, 20 volts. For now, I'm going to turn off the loads. Now you see the voltage rose up to 20.08 volts here, 20.03. These aren't super accurate necessarily, but good enough for our purposes. I'm really just concerned probably to about tenths of a volt as far as running laptops and other equipment. I mean, they're particular about the voltage, but not down to the hundredths of the volt particular. Next, something I'm curious about, and I'm going to pull this one out. I just have to be careful with these cables. I should have made these ends different lengths so that if I hold it like this, they can't short out. That was a mistake. Maybe version 2.0, although I guess I could just trim it right now, but we'll just walk on the wild side. So what I want to do is see what kind of leakage we have, if any, to ground. Oh, maybe because it's pulling such low amperages, keeps trying to auto range. Speaking of dangerous boxes, here is an Amprobe ADP TRSCT socket check adapter. Really, all it is this is actually a Chinese plug, so I think this might be a knockoff. It basically just taps live, neutral, and ground and breaks them out into banana jacks. And so to go along with that, I'm going to use this properly colored grounding clip, and I'm not plugging anything into the two danger holes, and then just plug that in to the mains. So with this probe grounded, put it in, start with DC volts, plug this into the power supply, 18.2 volts to ground. And then off the negative side, virtually nothing. But I don't think the negative side of this is going to be continuous to earth ground. No. And this adapter is grounded, by the way. I did have that Mickey Mouse plug. Actually, let's check that in AC too. Okay, and then there's about half a volt AC to ground, which is kind of what I'd expect. And you can see it's at 60 hertz, so that's just mains frequency coming through. But, of course, what current is going to ground? Then about the same off the negative side. And if I didn't see such a high DC voltage coming off this leg to ground, I would ordinarily just put the multimeter into amp range and just see what kind of current is there. Just like basically short it to ground. In a fully isolated power supply, that shouldn't matter. But if this is putting out 18 volts DC relative to earth ground, that might do a full whack of current, like the full 5 amps of current. This is probably overkill, but here we have a 100 watt light bulb, incandescent of course, with a tungsten filament, plug for the light bulb, and we'll go full Christmas theme with the meters. Basically all we have is the current going from the USB-C connector through the green multimeter, back out into one side of the light bulb, one terminal of the light bulb via this cable, and then ground on the other side. So basically current will just be flowing from the power supply to ground via both the meter and the light bulb. And the light bulb will limit current if it passes a lot of it and actually heats up the filament. And the resistance of the cold filament with all this cabling is 9.5 ohms. And it's a 100 watt light bulb. I don't think it's actually going to glow visibly, but let's see what happens. We got no noticeable current going to ground. And I kind of just want to test that isolation level of the power supply just to be sure before I start connecting my oscilloscope to the leads of the power supply. And you know what, just to be certain, I suppose it can't hurt to also check what's coming off the XT60 connector, because I don't know how this power supply is laid out internally. I'm assuming there's like a common isolated rail. My guess for this would be that it's probably a switch mode power supply that brings the voltage down to 20 volts, and then that gets distributed directly to the XT60 connector. And there's probably a secondary DC to DC converter, which would hopefully be bypassed if the USB port requests 20 volts and might kick in to drop that 20 volts down to 12, 9, 5, whatever the device connected to it requests. But so therefore, if that is the way this is set up internally, we might be seeing more isolation on the USB-C ports than we see on the XT60 port. We should have, if it's a good switch mode power supply, it should be pretty well isolated anyway. you know, we might have a little capacitive current leakage, but that won't actually do any harm in 99.9% of cases. So let me unplug the USB, and then all I'm going to do is put the output of the XT60 connector in exactly the same position and just make sure that these two ends don't short out. I mean, hopefully the power supply has short circuit protection. Again, that's not something I'm going to test till the end, because if that does blow it up, I won't be able to run any of the other tests without buying another one, which I don't really want to do if it blows up. So I'll put this meter on DC. I turned the power supply off using this switch just now, so turn that back on. And I'm not seeing any current on this meter. We should have 20 volts right there. And then again, if I go to ground, we're seeing that same 18.3 volts. Oops. Oops. Well, the good thing is, despite a spark and a little bit of a crack, it's still outputting 20 volts on this USB-C connector. So let's see if I actually did blow up the part of the power supply that feeds the XT60, or if it just reset. Nope, we still got 20 volts there. Alright, so I guess it does have short circuit protection. That's good to know, and it rebounds quite quickly. So anyway, turn the power supply off again. I think there was, let's see if there's a big capacitor in there. No. I mean, I'm sure there's a big capacitor in there.
Une mort d'éponge plus tard.
So for testing the noise, I have another piece of equipment here. It's not, strictly speaking, for testing the noise. It's for getting a baseline of noise. Show you what I mean. It's a Keithley 2280S 32-6 precision measurement DC supply. Obviously, this is going to be very low noise, so this should perform a heck of a lot better than this power supply. The idea behind this is I want to get an idea of how much noise we have from the environment and maybe noise that's back propagating from the electronic loads. Because these aren't what you'd call super high quality test equipment. At least these two really aren't, because they're kind of old as well. This isn't the most scientific test. Like, I wouldn't use this to qualify the instrument for production or as part of QA of any instrument or power supply for that matter. The point is just to get a general idea of how much noise this thing puts out. And as long as it's not a ridiculous or a comical amount of noise, then it's fine. You know, every switch mode power supply, which I presume this is going to be noisy to an extent. It's just, how noisy is it? That's what we want to find out. If it's barely measurable or barely discernible beyond what we see from this power supply, then it's fantastic. If we see significantly more noise, which we should, we have to determine if that's too much noise for the type of devices we'll be connecting to this. Because again, it doesn't really, strictly speaking, matter how noisy a power supply is, as long as whatever you're plugging into that power supply can itself handle that level of noise. Like if it has its own filtering, or if it's just something that's not very sensitive to noise. And obviously, these two leads are not ideal for testing noise because they're unshielded and they're just sort of hanging out in the air. They're not twisted together. This is an awful setup, but this is the same setup essentially that we'll have coming from this, which is just two leads with no shielding going into the load. So again, this is just to get a baseline of noise similar to what we may or may not expect from this power supply. For example, this is what we're seeing noise-wise. I'll take this up to, or down to 5 millivolts per division. This is just environmental noise, or any noise that's creeping through the power supply, which is now off, and the electronic load is also off. I mean, electrically they're both on, but they're not doing their thing right now. So I'll back this down to, let's say, 20 millivolts per division. I'm going to turn on the power supply, which is set to 20 volts, which is what we'll expect from the USB power supply. Go back to the scope, and so that's the power supply on, that's the power supply off. You can see the noise is about the same, which is understandable because most of this noise is coming from the environment, most likely, and not from the power supply itself. And I have the electronic load set to 5 amps, so we'll load down the power supply to 5 amps. And again, this is with the load on, pulling 5 amps. This is with the load off. The noise profile barely changed. It's not noticeable as how much it changed. And even if I bring it down to 5 millivolts per division, this is with the load off and the load on. Yeah, you can barely tell the difference. Bring it back down to 20 millivolts per division. I feel like I have to apologize for the slow update speed, because that's using a VNC viewer from this Siglent scope, and it is notoriously poor quality. Like, you can see the scope screen is updating at a fairly high refresh rate, but that not so much. But this is obviously much easier for you guys to see, and we're not looking to really capture anything quickly. We're looking for repeating noise, so this should suffice to at least give you an idea of what's going on this screen. And again, just visually on that, see a little dip in the output, but so that's with the load on and load off. This is AC coupled, by the way. That's why we're not seeing it move up or down with the voltage going on and off either. So if I turn the supply off. So now let me connect the output leads for the XT60 connector back up to this load. Okay, so what I've got going on here is 3 oscilloscope probes hooked up to all 3 of the potential outputs of the power supply. Nothing's connected to the power supply right now. They're all just kind of hanging loose. And you can see that's about the baseline of noise we're getting just from the environment. So on the bottom is trace number 1. I'm going to plug that into the XT60 connector. Let me turn the power supply on. That's quite spiky. And it's at quite a variable frequency too. And the amplitude's varying up and down. Like overall. That's weird because it's under no load right now. That's just it idling. Alright, well, let me solve that. I have this set to 5 amps. That's on the XT60 connector. Let's turn it on. Okay, and we got more noise in the other channels too. So that's with the load on. That's with the load off. So off, we're seeing about, it's not even symmetrical. The max voltage, it's jumping around quite a lot, but it's around 40 to 47, 50 millivolts. And the min is hovering around 30 to 36 millivolts on the negative side. And now if we turn the load on, again at 5 amps, a little bit out of range. Let me just shrink that down. So about 50 millivolts positive, 50, oh, yeah, it's all over the place, but it's still more positive than it is negative, the noise. Just for visual clarity, I'm going to scale this up. So these are all these traces are at 20 millivolts per division. So overall, though, that's not horrible. So figure maybe 80 to 100 millivolts peak to peak. If you want to look at it this way, from a high-level view, 1 volt per division. Now, the reason I chose that is because this power supply is meant to be used with laptops, cell phones when you're charging them, other sorts of devices like that. Those devices are usually going to be built with a fair amount of tolerance for voltage fluctuations. Because sometimes you might be using an out-of-spec power supply. I mean, if it's highly out-of-spec, it's going to be a problem. But even a slightly out-of-spec power supply, you can expect a 1 volt plus or minus difference on a 20 volt supply for a laptop, just because a voltage drop on the output cable, voltage drop on a poor connection the connector is making with the laptop itself, and you could have a power supply that's putting out a little more than 20 volts, like maybe 21 volts, and that shouldn't fry the laptop. So that's why I'm just demonstrating 1 volt per division. This line looks very flat, and that's a very good thing because that is essentially what the laptop would see. And you know, even if we're looking at half a volt per division, 200 millivolts, at that scale, it's just not very noisy. And that's this kind of scale we're talking about here. We're not looking for super low noise applications. We're looking to power consumer devices, which usually have some sort of filtering or voltage regulation of their own built in, or both. Now, I am curious to see what happens if I bring this up to the full 15 amps. Okay, it didn't get much worse, and the characteristics changed drastically. You can see we have a lot more ripple, which is understandable. And let me turn the load back off. So again, no load. Let it stabilize. And now 15 amps full whack. And on the min side, we're a little off scale. I'm just going to temporarily move this up. I'm really just looking at the measurements section on the bottom. So now we're seeing it's spiking up quite, I was going to say quite high, but actually quite low down to the negative side. I'm actually going to have to change the scale a little bit. Yeah, so it's going up to about 110 millivolts on the negative side and maybe 70 millivolts on the positive side. So we're looking at anywhere from 150 millivolts to 200 millivolts maybe peak to peak. It's really fluctuating quite a lot, so it's hard to pin it down. But again, that's not really bad for this application. And now we're back to 20 millivolts per division on all the traces. Let's turn this one off, and we'll come down to this one, which is the blue trace on one of the USB ports, and we'll set it to 5 amps. And it would help if I plug this USB connector in, and you can see that results in the same spikiness that we saw in the other trace. And now we'll pull 5 amps. And just so it's not going off scale, let me just zero that. Ooh, that's spiking real high. So this one's hitting about 115 millivolts on the positive side, max, and maybe negative 75 millivolts on the negative side. And now, just to see, what if we do another 5 amps on this, and we see a similar behavior to what we saw when we pulled 15 amps off of just the XT60 connector. But of course, this is 5 amps from each, so now we're pulling 10 amps total out of the power supply. And needless to say, the next thing to do would be to pull another 5 amps from here. And let's turn that on. And now we're pulling 5 amps from all of these. And so the noise profile in general looks the same on all the outputs, which I can't say I'm surprised about. And so that makes me think that maybe I was wrong about this having a 20 volt fixed output switch mode power supply for the XT60 connector, and then a DC-DC converter from that goes to the USB ports. Unless it is bypassing that. So, I should test out the USB output at a different voltage to see if we see the same noise or not. And the only thing I want to do is, now we're pulling a total of 15 amps across all these, which would be 300 watts at 20 volts. And so I'm going to bring this up to 6.5 amps. And that's going to be 330 watts total between all the outputs on our good old power supply. And that really didn't change the noise characteristics too much, which I didn't expect. I didn't think that 1.5 amps would absolutely throw it over the edge or anything. And it is getting warm. Almost what I'd classify as hot. Like, not too hot to touch, but it's really got a good amount of temperature on it right now, as one would expect. Now, the efficiency is pretty good. Let's go back to that for a second. So again, we have 330 watts being pulled out of this thing, and we have 352 watts going into it, so give or take. So it's about 22 watts of overhead still, which is not bad. And just for my own edification, I'm going to turn off the power supply that's pulling 6.5 amps off of the XT60 connector. So now we're just pulling 10 amps from it, which should be 200 watts. And you can see, therefore, we have about 13 watts of overhead. And if I kill another one of the electronic loads, that'll bring us down to 5 amps or 100 watts coming out. And we got about 108 watts going in. And again, with a really good power factor, so volt amps is going to be roughly the same. And then power back on those two electronic loads. And again, 352 watts. Now, the only other thing I'm somewhat curious about, I was talking about this Anker power supply earlier. I'm kind of curious to see how it stacks up noise-wise. And just to be clear, again, the reason the pink trace is seeing so much less noise is because it's coming off of the Rigol, which is off to the side, so there's not as much interference between all this cabling. And one thing that kind of drew me to this power supply is that it has a display. And you can see this port has 140 watts max on it. I do like how it tells you that right on the front. It's currently outputting 19.7 volts, which is weirdly a little low. Should be putting out 20 even. But let's load this down to 100 watts and see what we got. And we can see in the background here, we already have some spiky noise. And this is the same 20 millivolts per division vertically. And actually, let me turn off the other two traces just to make this a little more legible. We're getting about 60 millivolts on the positive and negative 35 millivolts on the negative. So maybe 95 millivolts peak to peak, which is also not bad. It's about comparable to the other PSU. And now I'm going to load it down. We'll just go straight to 5 amps. And obviously, there we go. The noise has become a lot more frequent. Unlike the other power supply, I mean, the differences are very small, but we're still at about 95 to 100 millivolts peak to peak. And let's look at this a little closer up. So yeah, 10 microseconds per division. At 50 microseconds per division, I'm going to turn the load back off. Yeah, we got some ringing on each cycle. Let's just see again. So load off, turning load on. But again, about 90 to 100 millivolts peak to peak, which I think is more than acceptable if we're looking at something on this scale. Though weirdly, I'm leaving it at 100 millivolts per division. I'm just going to turn on the other USB power supply, and I'm just going to swap this over to that one. This is like a little bit worse, but really not much. Like the Anker is a little bit better, but not by so much that it really matters. Yeah, it's definitely like a little spikier than the Anker, but not horrible. So yeah, overall, I mean, still think this performs a little bit better maybe, but only slightly. And I'm actually pretty pleased with this guy so far. Oh yeah, the other thing I wanted to see is if we can infer if there's a DC-DC converter in here after after a switch mode power supply. And again, my theory being that a DC-DC converter would handle stepping down from 20 volts to a lower voltage. So let me get a cable that I have around here somewhere that has a USB-C power delivery chip in it that's set to 12 volts. So we'll get a 12 volt output. One moment. All right, well, I could not find for the life of me one of the 12 volt USB-C cables that I have, but I did find this. And what this is just a USB-C port, couple of chips for, I believe, power delivery, maybe memory also, so that it can remember what it was last set to, a button, and this terminal block. The idea behind this is, if I plug it in here, LED lights up, and each time you press the button, it moves to a different voltage. And of course, this device doesn't regulate the voltage, it just has the power delivery chip, which demands the different voltages from the upstream power supply. And then you basically have a direct connection from the power supply through to these two terminals at whatever voltage you selected. And actually, just by way of example, I'll bring in the Anker power supply again. So you can see right now it's supplying 5 volts, and it's got a red LED. If I hit it again, 9 volts. And it's kind of got a yellow LED. It's the red and green both lit up at the same time. Hit it again, 15 volts. Weirdly, it skips 12 volts. 20 volts. And now it goes to 11, which I think should probably be 12, no? And then back to 5. And actually, I thought this had memory. Right now it's at 15 volts. Let me just pull the power. LED goes off, of course, and see if it comes back on green. No, it comes back on 5 volts. All right, fair enough. And just so I could connect probes to it a little bit more easily, got a couple of jumper wires. And these aren't even rising clamp terminals. These are just the smushy downy kind. Very cheap, this device. Forgot where I got it. I think I got this off Amazon. Then I'm going to borrow the scope probe off of here, which is the pink-purple channel. That's picking up quite a lot of noise. Yeah, and so that's just environmental noise. Not great. Okay, so right now I'll just leave it set to 5 volts. And with no load on the power supply, that's the noise we're looking at. Let me turn channel 1 back on. And so the yellow trace is what's coming out of the XT60 port. And we can already see the noise is very different. And those are both set to the same 20 millivolts per division. Now I'm wondering if I change this up to 20 volts. Yeah, at 20 volts, the noise becomes identical. So that's 5 volts, 9, 15, and then 20. So yeah, it's not conclusive, and I mean, I know some of you are probably screaming at me to disassemble this thing. I'm not going to disassemble it because the way this case is constructed, I'm pretty sure that's going to be a destructive operation. But that lends credence to my theory that it's actually 2 power supplies, or a power supply and then a DC-DC converter that's bypassed for 20 volts and that is in use for other voltages. Now that we know the noise is reasonable, the voltage is stable, it can handle a heavy load, no problem, just like a big diaper, I do want to try it with some laptops. And so to facilitate that, I got a Dell laptop, a Lenovo, and an Asus. Now of course those are useless with just the cable that the power supply came with, so I ordered adapters. That's Lenovo, that is Asus, and that is Dell. And I think they have other brands available, but these are the brands of laptops I have that will draw a decent amount of amperage. And so, well, the Dell one here really won't, but that's besides the point. That's the heaviest duty Dell I have. Now, the Lenovo package came with 3 adapters. 330 watts, 300 watts, and one that's labeled B. The Dell package came with 2 different adapters, one for, I think, the smaller, like, crappy Inspiron models, and then this one for the larger, probably Latitudes and Precision notebooks, maybe. You can see very different barrel plugs. And then the Asus just looks like this. Now, I definitely prefer the ones with the little pigtails, because that just adds a little more flexibility right after the connector, so you're not, hopefully, putting too much strain on the connector itself. Though these Lenovo connectors, despite being somewhat proprietary, or, well, very proprietary, I am a fan of them in that they're very chunky and heavy. We all know how these can sort of wear out if you bang it around a little too much or put a little too much pressure on it. But these, I absolutely hate, because we're going to have this chunky cable. Then imagine on Inspiron, you have this chunky cable with all these connectors and all this leverage here. Like, if you bang against this, right, you're putting a lot of leverage on this tiny little connector. So, not so much a fan of those. Actually, what the hell is this warning label anyway? Please do not use the SlimQ charger if the input voltage required by your computer is outside of the range of 19 volts to 20.5 volts. Doing so may cause damage to the computer or the charger, which makes perfect sense. And it does also make me think, to verify the voltage. This one, the Asus, takes 19.5 volts, and it'll draw 230 watts max. None of these laptops are super new, but they're the newest I have. In fact, this one has a manufacturer date there of 2021, and it's 20 volts, 11.5 amps, so that would be 230 watts also. This Dell is not going to draw as much current max, I don't think, because it doesn't have a GPU. 19.5 volts, 4.62 amps. So yeah, this is the lightweight. I'll plug in, I guess, the 330 watt version. And so this is why, though, I wanted to test this power supply in advance of actually plugging it into one of my relatively expensive laptops. You know, like, I wouldn't recommend anyone go out and just buy a cheap, not this was that cheap, but a cheap or off-brand aftermarket power supply unless you have some good information on how it was tested, hopefully by a third party, like me, for example, to know that it'll be reliable. Now, that doesn't mean this thing can't blow up, not completely, but something in there can't blow up. It can't have an internal fault that causes it to suddenly output 40 volts or maybe mains voltage straight to the output. I don't know. I mean, granted, that could happen with any power supply, even one made by the manufacturer or outsourced by the manufacturer themselves. The cheaper the power supply and the more off-brand it is, I feel like the higher the probability that something like that's going to happen. And I think this warning label is actually quite useful. I usually hate warning labels on the end of extension cords or leads because they're just pretty pointless. But what I am going to do, I think, is replace this label with one of my own from a label maker that just says 20V for 20 volts in big letters on both sides of the label. So this way I remember that this only outputs 20 volts. And I remember to double check the voltage requirements of the laptop. Although I didn't really buy this for laptops, but I do want that option if I'm traveling. Although I usually travel with a laptop that just takes USB-C power input, but in case I'm traveling with one of these heavier duty laptops with built-in GPUs. Alright, since this video isn't really about showing off the laptop's functionality, I'm just going to point a camera at the screen and not do anything fancy to show you the video coming out of it. So let me turn the power supply on. And I'm still monitoring the power that's being consumed by the power supply, which right now is, it looks like it keeps trying to start up. That's interesting. It's at 0.28 watts, but it spikes to 4 to 12 watts very briefly, because I'm assuming it's checking if something's connected to it. Maybe it's powering itself up and powering down. So that's surprising, and that's really good. Its standby current is almost nothing. It's usually about 0.05 amps maybe at 120 volts, with occasional spikes up. So that's actually really good. And now presumably if I put a load on it, now it's consuming 56 watts. The laptop's power light is on. The connected AC adapter has a lower wattage than the recommended AC adapter, which is shipped with the system. To use AC power, please blah, 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 blah. Man, that screen is dim. Let me just brighten that up a little. Oh, why'd it go off? Oh, it really doesn't like this power supply. So real quick, let me see. What if I use... I was using the little dongle labeled 330 watt. What if I use the one labeled 300 watt? But let's see if we get the error message again. Oh, okay. That time it didn't complain. So, well, I guess these, to be fair, I don't know how Lenovo's discern between connectors. Oh, just restart. Who cares? The way these are arranged is there's an inner pin, and then of course this is presumably the shielding / ground, but then there are also conductors on the other sides of the pin. So I'm guessing there's some kind of communication across at least a couple of those pins, or one of those pins and ground, to the laptop. So maybe each of these two dongles has a slightly different, maybe resistor, or like an old school USB, or whether they actually have some kind of chip that talks to the computer. I'll look it up and I'll put my findings on screen now. Anyway, enough waffling. We could see we didn't get the error message, and now it is showing as charging in Windows. I was gonna... I don't think I have Steam on this laptop, actually. Yeah, no. But I do have World of Warcraft. What I want is just a way to make this sort of max out its CPU and GPU, which I don't even remember what's in this. For those of you that are curious, it's an i7 10750H, which is a 6-core, 2.6 gigahertz base speed. Got 32 gigs of RAM, a 1 terabyte SSD, and a RTX 2060. And I guess I never connected this to my Wi-Fi at home. Well, fortunately, one of the things that drew me to this laptop is that it has an Ethernet port, which is shockingly rare nowadays. I guess we'll just use Passmark. And incidentally, going into the power supply, pulling from mains, it's oscillating between like 35 and 60 watts. Now it's stabilizing around 50. So we're really not pushing it very hard right now. Let's just run the 3D tests. Kind of as expected, now we're up near 120 watts. But I don't think this is pushing it all that hard. We're getting 140 FPS on this test, which is 1920 by 1080 by 32-bit color. Well, anyway, it is kind of pointless to load test this because, I mean, even if this laptop pulled its full 240 watts, that wouldn't be enough to exceed the power supply capabilities. And really the highest wattage I've been seeing is about 120. So, because this is pushing the GPU very hard, but not the CPU. Now 135 watts it hit for a second, but that's with overheads. The laptop's actually consuming less than that. So yeah, it's a RTX 2060. Obviously it's not great. That was a given from the start. When I'm recording this video right now, the 50 series has already come out, so this is 3 generations behind. I kind of got carried away there because I really just wanted to show that it did work with the laptop, but this adapter works as long as you're using the right adapter for the right laptop. Now, usually I'll buy a laptop, well, either it's going to be my daily driver, which I usually go for Lenovo X1 Carbon because it's thin and easy to carry and fairly durable. They've never really let me down, but they're not super performant either, and they don't really have any amazing party pieces. They're just solid laptops in my opinion. And this one only came with the one cable, so it's either this cable works or it doesn't. This is great for video editing because you can have the timeline down here and video previews and your media up top. Really like it for that. And one thing I don't like about this laptop is, at risk of this turning into a laptop review, it doesn't have any ports in the back because of the way the screen sort of overhangs. You can see the base of the laptop rises up. So it does give it a nice angle to work at on a desk, but not so great for a lap. It means there can be no ports in the back, which I do like. That was another thing I like about the Lenovo. It only has one HDMI port, one USB Type-A, one USB-C, headphones, and another USB-A. So it's very skimpy on ports. And this one actually is connected to the Wi-Fi. And just because I know someone's going to ask, and I don't remember the specs of this thing offhand, oh, it has exactly the same CPU as the other one, i7-10750H. It also has 32 gigs of RAM, which I did upgrade myself because this didn't come with 32 gigs. It's got Intel UHD graphics, which drives, I think, one of these two displays. I'm hoping I think this display down here. And then it's also got another RTX 2060 to drive the main display. Yeah, so they're basically the same laptop, spec-wise. I do believe this is an OLED, though. Oh, and this is a full 3840 by 2160. All these laptops came off eBay, by the way. They were in like-new condition. I can't buy all these laptops brand new. And they were already like a year or two old by the time I bought them. All right, so the Asus adapter works. And then, last but not least, we'll try out this rugged Latitude. And this is for like trips to the data center and that sort of thing. Actually just recently got this. Haven't even loaded my own OS on it. This is probably gonna have Linux. And one thing that is good about these is it's got a lot of ports. Got a USB-C port, but is labeled just display port. And of course, for data center use, it has an Ethernet adapter as well as a serial port, which, you know, not that useful nowadays, but becoming more and more useful. Correction, 2 serial ports and 2 Ethernet adapters? Well, shit, that's nice. But I digress. Weird thing is, power connector is not covered by anything, which again, on one of their really rugged ones, is not something you would find. And that's going to be this style of connector. The charging indicator / power indicator is on, so that's cool. The camera is open for some reason. Backlit but not waterproof keyboard. And this is pulling a mere 30-ish. It spiked at 60 briefly. But obviously this isn't going to pull much in the way of power. And yeah, brand new. I'm not going to bother going through the setup right now. But suffice to say, based on the LED situation, I'm going to say that it is charging. But no complaints on the adapter anyway. So yeah, I'm going to count this as a success. I mean, probably on this tougher laptop, I'm hoping that barrel connector internal to the laptop is not just soldered to the motherboard like usual. Because like that's just the worst. And look how much leverage we're coming out this far, and then we're coming out to here. So if you were to like push on this here, think about the amount of leverage and force that's going into that barrel plug. So I really don't like that. I mean, it's better that it's going at a right angle, I guess, than sticking straight out the back, where it could really get torqued badly. Or if someone pulls on this cord, if you trip over this cord, I mean, you're just going to rip the barrel plug sideways right out the ass of this machine. I personally am not a fan of this at all. Although, to their credit, I didn't say this before, but this cord is extremely flexible. I mean, like, very flexible. Almost too flexible. Like, they're either using very thin strands in these conductors, or they're using very small bundles of strands. And they've skimped out, as a lot of these products do. Same with the AC inlet cord. In fact, this is one of the most flexible line voltage power cords I've ever seen in my whole life. I mean, it's also very lightweight. In fact, how lightweight is it? So here is another North American to Mickey Mouse style cable. This one is really kind of chintzy. It's not like the cheapest and thinnest I've ever felt, but it's not high quality. It says 18 gauge, which is 0.824 millimeters squared. That's another thing that kind of sketches me out about this cable. Now, of course, they can lie on the jacket, and it doesn't give the dimensions of the conductors. So you probably know where I'm going with this, but these are just about the same length as each other, like plus or minus a couple of centimeters. I mean, I should just cut it open and see what the conductors look like, because I really am not comfortable even using this little uber flexible cable without knowing what's inside. 125 grams. And this one, which is 125 grams. I guess it just feels lighter because it's less dense, because this jacket is ostensibly thicker. So the fact they weigh exactly the same down to the last gram, it just makes me further concerned, because this is probably some kind of braided, well, it's definitely braided, but I don't know what kind of material it is, but it's probably over some kind of plastic insulation. So this is probably a double jacketed cable, which, you know, in theory is fine, but that extra jacket should probably make it way more, because it's also thicker than this cable. So you would think the one with the thicker jacket would weigh more. Now, of course, this one might be copper, and this one might be aluminum also. You know what? In the name of science, like I said, I don't want to ruin the power supply, but I'm not averse to ruining the power supply cord, because these are a dime a dozen. So yeah, we have this flexible jacket surrounding a very flexible, it feels like silicone jacket, which then it's about the same thickness as this guy. Yeah, kind of stripped the ground a little, but that's fine. And it does feel like this is also, like the actual insulation on the conductors is silicone also. So that could explain the weight difference as well then. Just completely different jacket materials. Like this probably has PVC insulation. Yeah, these aren't as thin as I was worried about. And are they copper though? Yeah, they're bending like they're copper. Oh, they also have strain relief strands. Oh, well, that would help make it thicker. There's like nylon string or whatever material that is, which the strands are actually wrapped around. So that would add some artificial thickness to this whole thing. And it's going to make measuring the effective diameter here kind of difficult, because I'm going to have to twist it together, but I'm not going to get the twist as tight as it would have had in the factory. Well, the digital display on this is broken, and the scale isn't really that accurate, the visible scale. It's only down to millimeters. So yeah, that's about 1.1 millimeters in diameter, assuming we're at 0. Yeah, I'm seeing that as like 1.1 millimeters in diameter, but again, that's with my retwisting of it. Yeah, I mean, it's saying 17 gauge, if that's correct. And just to double check that this is copper. It's hard to tell on camera. Let me see if I can, I'll take a macro picture of it with my cell phone. Alright, so I had to take a really close look. And in the lighting down here, at first I thought it was copper-coated aluminum, but it was really just the way the light was hitting it. Like, I definitely got that all scraped down right there. And you can see in the shiny parts, it definitely looks aluminum-y, but it's definitely copper. Well, okay, it looks like I have to give my heartfelt apologies to the company selling this, because this cable does actually appear to be pretty decent. Yeah, I'm sorry about that. It's just the same weight as this cable with fewer jackets, because it has silicone or silicone-like jackets in addition to this braided nylon or whatever the hell it is. So this is actually, and then it also has strain relief in each conductor, or I guess in each bundle of conductors. But does the ground actually have one of those too? Yep, even the ground. So this is actually a really high quality cable. You know, despite the fact that I couldn't measure it hugely accurately, I would say it's about 18 gauge. And just as a point of reference, 18 gauge cable of this general type is, and for this general purpose, is usually rated at 10 amps, which is obviously more than enough to supply a 330 watt power supply, because even at 120 volts, of course, 10 amps would be 1200 watts. So technically this cable is actually overrated for this power supply, as it should be, for safety, but an 18 gauge is about what you'd expect with most any of this type of cable anyway. It's unlikely you'll find a 16 gauge with a Mickey Mouse plug, because those are rated for lower ampacities. And actually, as you can see, this one is at least copper coated on the inside. Okay, right off the bat, I like this connector better, because this connector has a full copper looking sleeve around the pins. The copper comes fairly close to the edge of the connector, like the copper ends about there. So you'd be getting good penetration between the two connectors. But this one, it looks like the copper ends about, or the conductors in the connector end about there. So you'd be getting much less overlap between these conductors and the conductors in the connector. Which, I mean, again, for this kind of amperage, not a big deal, but it's also just not as much metal in there around the whole thing. So this connector I'm not as much of a fan of. Now, this plug looks fine though. So let me get to the point of why I purchased this power supply. It's because it has a high amperage 20 volt output and also a couple of USB-C outputs and a total of 330 watts. That's important because of this other box that I purchased with the power supply. Well, it didn't come with it. I mean, I purchased in the same Amazon order, and you can see it's labeled Star Gear. That might give you a clue. And this has an XT60 connector, which I'm now just freaking realizing is the wrong type. Well, anyway, in principle, XT60 connector on one end and DC barrel plug on the other end, but not just DC barrel plug. It also has these flanges on it for getting a watertight or relatively watertight connection with a Starlink Mini. And if you read online, you'll find that a Starlink Mini can be powered by a USB-C power supply that can provide 100 or 120 watts. People are sort of divided on that. The problem is when I took it and went to test it with a power supply that was more than capable of putting out 5 amps at 20 volts, which would be 100 watts, or 6 amps at 20 volts, 120 watts, it would still, that being the Starlink Mini, crap out because it pulls current in a very pulsed way. So it might pull current an average that would equate to an average of 100 or 120 watts at 20 volts, but it pulls spikes of current much higher than that, and therefore, if your power supply, as a lot aren't, is intolerant to overshoots or transient overcurrent, then the power supply shuts down, and your Starlink Mini shuts down and then boots right back up because the power supply recycles. And so you end up with it just basically an infinite reboot cycle. And this got me the first time I tried using the Starlink Mini, because my plan had been to use it as a portable satellite terminal or interface while traveling with a USB-C power bank. And I got one that is powerful enough to supply it, in theory, based on everything I read online, but the power bank would actually shut down. And then I tried it with a couple of USB-C power supplies, not this one, but chunkier ones that could supply 100 watts, 120 watts, and they would also periodically shut down. Problem is the Starlink Mini doesn't consume high current or pulses of high current right on startup. It doesn't really start doing that until it's trying to communicate with satellites. So it'll go through a little bit of the boot process before it actually activates the antenna and starts transmitting data, which aside from the built-in heater is really the most current intensive part. And so when it's trying to really transmit and receive, sometimes it won't be until you really have data going back and forth and the antenna is really pulling more current, then it starts shutting down a power supply that can't handle those pulses of power. That's a whole side tangent, a subject for another video. The point is, for the Starlink Mini, now granted this isn't truly portable because it does require mains AC, I figure for travel where mains AC is likely to exist, but maybe internet service is not, or for example with a generator, this would be a great solution because it will definitely provide enough current on the XT60 port, as we've discovered, and it will also provide simultaneously enough current on one of the USB-C ports to run a laptop. So therefore you have your satellite interface and your laptop powered off one power supply. So I really bought this with that use case in mind. A side benefit, and the reason I got the laptop power adapters, other than demonstrating them in this video, is so that I can also use this with my higher current draw laptops. And so this way I only have to pack one large power brick rather than the large power brick for the laptop plus a relatively hefty USB-C power supply to charge my cell phone, charge whatever other devices I have with me. And yeah, it just might simplify things there too. So for those two use cases, I think this is a pretty decent power supply. The only thing we have yet to see is, can this thing supply its max current for a sustained period of time? And I am going to be fairly nice to this thing because I don't want to blow it up. As the little instruction manual said before, when it's operating at 320 watts plus or minus 10 watts, the orange light will start flashing that you can't see anyway. And according to the manual, that means the device is operating under stress. So it's 330 watts max, although I can go a little over that apparently, plus or minus 10 watts on all the specs. So I am going to stress test this long term at 300 watts even. I do think it should be able to handle 330 watts for hours at a time, if that's what it's spec'd for. But I kind of don't want to ruin it. And I think if it could supply 300 watts for, let's say, 4 or 5 hours without getting ridiculously hot, then success. This will be a fine product for me. I don't really want to use power supplies near their rated maximum or at their rated maximum for long periods of time, because that can cause them to experience extreme thermal stress, which will cause them to either break now or at some point in the future. It'll degrade the capacitors, it'll degrade other components. Generally speaking, I like to get power supplies that are overrated for my application by maybe 20 to 50%. So if this can supply 300 watts sustained for hours at a time without, like I said, melting down or becoming catastrophically hot, then it's a keeper. Because I don't want to sit here for 4 or 5 hours watching it, what I'm going to do is set up a GoPro. So yeah, that's the setup. You can see I have 2 electronic loads running here, and that's because I'm pulling 7.5 amps from each of them, again at 20 volts, making 15 amps total, 20 volts, 300 watts. And that's just because I also don't want to run the electronic loads at their spec'd maximum of 300 watts long term. So I figure run them at half load and we should be good. And so yeah, that's the setup. I will fast forward through that. I haven't done it yet, so I'll be back with the conclusion of that test and the conclusion of this video. Actually, you know what? I'm not even going to bother going back to the studio. If this video ends with me just showing a time lapse of the test and showing some thermal results and me not talking to you again, that means this thing worked fine for that period of time. If it failed, we'll look at it in more detail. So thanks for watching. I might be back. Alright, I know I said I'd only be back if this thing failed, which it did not. I guess I can get these cameras out of the way. I say it didn't fail necessarily or strictly speaking, but it's been 4.5 hours of it running at 300 watts, as you just saw. The voltage looks good. There was a little bit of voltage drop, but not much. I'm not too concerned about that. It obviously is still supplying the full current. That's not the issue. The issue is the thermocouple is probably a little off, or rather the multimeter probably isn't calibrated, and I have these insulating gloves for very good reason. For you see, this thing is way too hot for me to touch. Well, okay, I was a little premature putting the gloves on because I don't need to touch it just yet. What I do want to take a look at it through is infrared camera. And so according to this Fluke camera, our hottest spot there is actually more like 85C and not the 78 that the multimeter was showing with the thermocouple attached. And the hottest point is right about where the thermocouple is. So maybe it's also because the thermocouple is just a little bit off center. I don't know. And the reason I haven't picked it up to show you is because I want to get a fresh thermal image of the bottom while it's still under load and still fresh before it can sink its heat away from the bottom. So see how hot that is. Oh, 101 degrees. 100 degrees, yeah. At its hottest point anyway. I didn't really look at the sides. I mean, the hottest is on the top. At the bottom. How hot is my desk? I mean, my desk is 82 degrees. This is what I mean about it not necessarily... Oh, is the connector hot? Connector looks a little warm at least. And I can even feel the heat through these gloves. And these gloves are meant to pick up really hot things and take tips off soldering irons and stuff. So this thing is ridiculously hot. I'm kind of curious to see if the voltage drifts back up a little now that it's vertical. And even though I dare say the multimeter is not accurate because both thermal cameras agreed, and it was a little off when it was at ambient. We're at 19.65 volts on top, 19.69 on the bottom. It was at 19.7 something, I think, when I started. I'm just wondering if that will go up a touch. And yeah, the bottom's already cooling down quite a bit at 91, which, you know, is not exactly cool. I mean, even the top of the thing wasn't cool. Yeah, this is almost too hot to hold with the gloves. This is madness. I wonder if the cables are warm. Not because the cables... Yeah, these cables are really warm, and it's not because they're not thick enough. These are 12 gauge. So these cables should handle the current no problem. And they get a lot cooler. Yeah, the cables are just a little warmer than ambient far away from the device, but right up close to the device, it's sinking heat into the cabling. So, yeah, now it's been... I mean, it did hold up. It's been almost 5 hours now of it continuously putting out 15 amps at 20 volts. So I'm pretty pleased with that. But I'm overall not too enthusiastic about this device, seeing as because the amount of heat this generates, I wouldn't be comfortable using it for an extended period of time at full load or near full load, especially unattended, because and I am worried to think what happened to all the components in here, because the surface of the bottom was at 100 degrees C. That means that internally the components much hotter than that. I mean, let alone the silicon, like inside the dies inside the actual chips that are in here. Some of those must have been absolutely baking, especially if any of them are the source of the heat. Again, I know people are going to want me to disassemble this and look inside. I still need to keep it just for now so that I can use it for my own purposes, but not at anywhere near full load. Maybe at like 200 watts max, because this is actually frightening. I mean, common cause of house fires is a faulty electrical device or a space heater or something in a bedroom. People end up throwing clothes willy-nilly or blankets. They throw their blankets off the bed or something. Lands on a space heater, lands on some other really hot device like this, insulates it, and then the heat has nowhere to go. It just gets hotter and hotter until eventually it gets hot enough to start a fire. Wow, this is really hot through the gloves, damn. So, you know, I don't know how this would behave. I have to imagine if this had thermal shutdown, it would have shut down. I mean, the inside of this was absolutely baking if the outside was at 85 degrees on the top and 100 on the bottom. If it's made with components that can withstand those temperatures, but like I said, internally it was going to be even hotter, at least especially locally at certain points on the PCB inside this thing, the heat was just going to be incredible. And it's a shame that it's a plastic case, because it does have a grounding connection, so it could have been a metal case and still been safe. And I was going to say, if they attached heat sinks directly to this case and it was metal, I mean, I wouldn't be shocked if points on the case got up to 150 degrees C. Like, this is hard to hold with these thermally protective gloves that are meant for this. Yeah, this would burn me if I picked it up fully in my hand for more than a couple of seconds. So, like, if someone's absent-mindedly like, oh, I was just using 2 laptops powered off this thing, let me go pick it up and just put it in my suitcase now that I'm done, and they pick it up fully in their hand, they could burn themselves, especially on the bottom. 100 degrees C for a few seconds, you get a first degree burn at least. So for that reason, I can't recommend this thing. And that's why I came back at the end of the video, because even though it didn't fail in that it stopped working, it failed the test in that it's literally too hot to hold. And that is sketchy to me. Now, like I said, I'm going to keep it, I'm going to use it, but I'm going to be very cognizant of looking out for its heat profile, making sure it's not getting this hot, and I'm only going to run it probably at like 200 watts max in general use. So I think with that caveat, if you're careful with it and you know it's going to get super hot, then yeah. And I don't think 4 hours is unreasonable. It got really hot. If we look at the multimeter and sort of rescale it, I mean, it got up to this temperature fairly early on in the test. So you're using this for a gaming laptop and let's say another USB device, maybe charging your cell phone too, something like that, and it actually is putting out 300 watts. You know, you could easily do that for an hour or two, right? Deep in a gaming session. Yeah, dangerously hot in my opinion. At the very least, dangerous if you pick it up and burn yourself. Possibly, and I don't want to be alarmist. I don't want to be like, you know, YouTube face. Yeah, like, oh my God, this is going to burn my house down. I don't know. I don't know what would happen if I threw a pile of clothing on top of this on carpet where it was well insulated and the heat could just go up and up and up. Or if I was using this outdoors in like Arizona in the summertime and the sun was beating down on it. Like, I don't know how it would behave if it really overheats. Because in my humble opinion, any power supply should shut itself down, or at least thermally throttle its output when it gets too hot for a human being to pick it up and touch it. At least for a consumer device like this. You shouldn't require protective equipment to use a laptop power supply. And I've been around laptop power supplies that got pretty hot. In fact, too hot to touch for long, but not so hot that they're like burning hot. If they are, that's a problem. I'm going to derate this down to 200 watts. And I think for safety reasons, it should be sold at 200 watts and probably shut down if it got anywhere near 300 for any extended period of time. Yeah, not happy with this overall. I mean, I was happy with it. I was very happy with it. It seemed like really good quality up until that last test. It's just the 330 watt thing is writing checks that its ass can't cash. And I was only running at 300 watts. It should supply 330 plus or minus 10 watts. So in theory, you should be able to push this to 340 watts. And then maybe we would have seen magic smoke. I don't know. But this is unbearable, even with the gloves. So yeah, that's the story with this. If you want a decent high amperage power supply that has an XT60 connector and the ability to power gaming laptops or workstation grade laptops, it's not a bad choice as long as you know the caveat. So anyway, thanks for watching. I'm going to record a portion to stick in the beginning of the video because no one's going to watch this entire thing. Well, some people will, but I mean, like, most people won't. Damn, these gloves. My wife's going to think I've been fooling around with a Muppet. What the hell?